Properties of logarithms. The first property we're going to look at is the product property. When you have log base b of m times n, that's equivalent to log base b of m plus log base b of n. So we're going to take whatever's multiplied and separate them and give them their own log base b. So let's go ahead and work an example where we expand the logarithm. We have log base b of 7x. Since the 7 and x are multiplied, that's what we're going to separate to get log base 8 of 7 plus log base 8 of x. And then let's work an example condensing each logarithm. Here we have log base 3 of 6 plus log base 3 of 5. Since we have the same base, we can condense this logarithm. So we have log base 3 of 6 times 5. And if we want to simplify that, we have log base 3 of 30. Why don't you go ahead, pause, try example 2 from the expand and condense, and check back with me when you're finished. Hopefully you got log base 5 of 9 plus log base 5 of y for example 2 in expanding, and log base 2 of 24 in example 2 of condensing. Next we'll take a look at the quotient property. Log base b of m divided by n is equivalent to log base b of m minus log base b of n. So we're going to take whatever is divided. In the top, the numerator is going to be the first one, and then the denominator will be the second one. It's really important what order you put this in because we have subtraction here. So let's go ahead and work an example on expanding. We're going to take log base 8, and remember the numerator comes first, of x, minus log base 8 of the denominator, 3. And then let's work one example condensing. So since our bases are the same and we see the subtraction, that means we're going to divide, and remember it's the first one divided by the second. So we have log base 3 of 8 over 2. Now we can simplify 8 over 2. 8 divided by 2 is 4, so this is actually log base 3 of 4. Now I want you to pause, try example 2 from expanding and condensing, and then check back with me when you're finished. Hopefully you got log base 5 of 7 minus log base 5 of y for example 2 in expanding, and example 2 in condensing. Hopefully your final answer was log base 2 of 3. Next, let's take a look at the power property. Log base b of m raised to the p power is equal to p times log base b of m. So basically what happens is if you have an exponent, you're going to bring it down in front of the log as a coefficient. So let's go ahead and expand this logarithm. We're going to take that exponent, and remember we're going to bring it down in front as a coefficient. So we have x times the log base 8 of 7. And then let's work on condensing. When we see this coefficient in front of the log, we're going to take that and bring it up as the exponent. So we have log base 3 of x squared. So go ahead and press pause, try example 2 in expanding, example 2 in condensing, and then check back with me when you're finished. Hopefully you got 9 times log base 5 of y for example 2 in expanding, and for condensing, log base 2 of 8 to the y power. Next, we're going to work out a few examples that are a little bit more complicated. Instead of using one property at a time, we're going to combine a few of the properties together. If you feel comfortable, I want you to go ahead and try these on your own and check back with me when you're finished. If not, you can stay with me and we'll work through these together. So let's take a look at example 1. We have log base 5 of 125 divided by x times y. So we have two things going on, division and multiplication. Let's take care of the division first. We have log base 5 of 125 minus log base 5 of x times y. Next, we'll be able to separate the x times y to make this log base 5 of 125 minus log base 5 of x plus log base 5 of y. Now before we move on and simplify any further, we need to do one more thing. If you notice in the original problem, x times y is together in the denominator. So we need to make sure that as we are working this left to right, if we were to condense this, we would get the original problem. In order to ensure that x and y are together on the bottom of the fraction, we're going to need to put parentheses around the log base 5 of x and the log base 5 of y. Now the last thing we want to do is simplify any logs we can into numbers. So here we have a variable, here we have a variable, but here we have log base 5 of 125. Remember, if we take log base 5 of 125 and set that equal to a variable, we'll just use a, and if we convert this, this is 5 to the a power equals 125. So 5 to what power gives us 125? This is actually going to be 3. So we have 3 minus log base 5 of x plus log base 5 of y. And here's our final answer. Next, let's take a look at example 2. We have log, and because the base isn't there, remember that means it's the common base of 10. So log base 10 of x squared, y to the negative 1. Let's take care of that negative exponent first. Remember, we can always change negative exponents to positive ones by moving them to the other place in the fraction. So if it's on the top, we move it to the bottom, and then it makes that exponent positive. Now we can go ahead and expand this. So again, we have multiplication, x squared times y squared all over y. So let's take care of that division first. Log base 10 of x squared y squared minus log base 10 of y. And we don't need to put to the first power. You can if you want to, but it's not necessary. Then we need to take care of this multiplication. So we have log base 10 of x squared plus log base 10 of y squared. And again, so that we can make sure that this is grouped together on the top, let's put parentheses around that, and then we're going to subtract log base 10 of y. The last step is taking these exponents and bringing them down front as a coefficient using the power rule. So we have 2 log base 10 of x plus 2 log base 10 of y minus log base 10 of y. And this is going to be our final answer. Next, let's take a look at example 3. Example 3, we have log base 3 of 9 times x to the 5th. So we do have this exponent, but we want to take care of this multiplication first. So we're going to have log base 3 of 9 plus log base 3 of x to the 5th. Now that we're done dealing with the multiplication, we can bring this exponent down in front using the power rule. So we have log base 3 of 9 plus 5 times log base 3 of x. Now the last thing is we want to make sure that we simplify everything possible. Here we have log base 3 of 9, so we can actually turn that into a number. So remember, we're going to take our log base 3 of 9, set that equal to x, and do our conversion. So we have 3 to the x equals 9. So 3 to what power equals 9? X is going to be 2. So this is actually the number 2. So we have 2 plus 5 times log base 3 of x. And this is going to be our final answer. If you work these out by yourself, hopefully you got them right. If you didn't, that's okay. We'll have plenty of time for more practice. Now we're going to do this one more time, except this time with a few complicated problems using condensing. So make sure to condense and simplify where possible. If you feel comfortable, try them on your own and check back with me when you're finished. If not, let's go through it together. So as we look at this, we know that the bases are the same, which is good, and then we know that subtraction is going to change to a division, and this coefficient has to go up as an exponent. So we can do this all in one step, or we can do it step by step. Let's take care of this exponent first. So we're going to have log base 3 of x minus log base 3 of 7 raised to the second power. Now that we've brought that coefficient up, we can bring these two together and combine it into a division problem. So we're going to have log base 3 of x over 7 squared. And our last step, we can simplify 7 squared. So we have log base 3 of x over 49. And this is going to be our final answer. In example 2, again, we have common bases, which is good. We don't have any coefficients that we need to raise as exponents, but we do have this plus sign, which is going to change to multiplication. So we're going to take the log base 4 of 5x times 3x. Now when we multiply this, we have log base 4. 5 times 3 is going to give us 15. X times x gives us x squared. And that's going to be our final answer. Let's go ahead and work through one more. Here we have log base 4, which is good. We have this coefficient that needs to be raised as an exponent. And then we have this subtraction that's going to change to a division. So let's take care of the exponent first. We have log base 4 of 6 raised to the second power minus log base 4 of 9. Now we can take care of the division. Log base 4 of 6 squared over 9. If we continue simplifying, we have log base 4, 6 squared is 36 over 9. And let's keep going. This turns into log base 4 of 4. And now when we have log base 4 of 4, we're going to go ahead and set this equal to x, and then we'll convert this. So we have 4 raised to the x power equals 4. So 4 raised to what power equals 4? X is going to equal 1. So our final answer is actually 1. Hopefully if you tried this on your own, you got the right answers. If not, that's okay. I'll see you in class for more practice.